a lot of definition stuff after a few group kind of meet and greets. One that was a little more exciting, the other one didn't have any math in it. Or maybe that's the other one. One thing I want to go over is problems in 46 or so. Let's see, these kind of problems here, yeah. And let me remind myself, I don't want to do your homework for you. And you're all like, it's fine, Jeff. 45, okay, so we'll do like 46, 45, 48, yeah. Oh, yeah, so we could do 42, sweet. Yeah, okay. Let me kind of zoom in. Bum, bum, bam, bam. Close that, go away. All right, so this section of homework right here, right? So the first homework assignment, I think, is 1 through 5, and then it goes to 45, blah, blah, blah. You guys all with me? 1 through 5, of course, are in the section titled practice, right? You remember that? Practice? That's where it starts off, and then homework is just another section of the assignment. Last time we talked about population, sample, variable, data, parameter, statistic. We talked about those definitions. So that's what this one here is all about. Let's take an example here. We zoom in a little more. All right. So this one asks you, so I always get somebody who turns this in and they say B, C. No. Identify all of these for each problem. Are you with me? Okay. And it says give examples where necessary, and I'm sorry, we're probably not going to stay here because I'm like, there's not another screen, so you guys, I have no idea if you can see anything that's happening. So for example, the very first one, a fitness center is interested in the mean amount of time a client exercises in the center each week. What would the population be? So remember, what do you think about it? Who are they trying to say something about? The whole group they're trying to say something about. Who are they trying to say something about?
The clients.
Clients of what?
Fitness center.
Which clients?
Ones that
So, good. All clients of the fitness center. You guys with me? If you just say clients of the fitness center, that's not specific enough. Say all clients. Now I know you know it means everybody, right? I like it. You guys with me so far? So it's not going to tell you. You got to figure out for this situation what is the population. Okay. So the population here is all clients of this fitness center. The sample is where you can give an example. So what's a possible sample we can take? And the funny thing is, the population is all clients of the fitness center. A sample would be replace the word all with like a number. You guys understand? Because the population and the sample are the same, except the pop is everybody and the samp is some, right? So population is all blah. Sample is like 100 randomly selected blah, right? Does that make sense?
Yeah.
Or you can even just say a subgroup, but you could be a little more interesting, say 117 randomly selected clients of the center. You guys with me? So that part you can kind of just give an example. Okay. Trying to cage your face, but again, a lot of you guys are really good poker players. Parameter. What the hell does parameter mean? Sweet. So the population and the sample are groups of things or people. The parameter and the statistic are descriptions of those groups. Numerical descriptions. So in this case, what is it that they want to know? It's the parameter, so it better describe the population, right? So what is it they want to know? What is it they want to figure out? Good. The mean amount of time. Now remember, it's got to describe the population. Just throw the population. The mean amount of time that all clients of the center work out each week. You guys with me? That is a numerical description of a population. You guys really with me? So if I ask you what the population is and later say parameter, whatever the hell you said for population better show up in your answer for parameter, because the parameter is supposed to describe a population. Okay. And remember, parameter population is really nice. Math, we don't do that all the time, but that's one situation we do. The statistic is going to sound almost exactly like the parameter, except it's got to describe the sample. So my example was 117, so it would be the mean amount of time that the 117 randomly selected clients work out each week. So one just says all clients, and the other one says 117 specific ones, right? One talks about the population, the other one talks about the sample. Not a big deal. Parameters in statistics are almost always means or percentages. Okay. Is everybody really good right now? Are you guys really good? This is what you got to do. This is not one of your homework problems, so don't get excited. But this is a nice one to have as an example, right? What about the variable? Does anybody remember what the variable related to? The question that's going to be asked. So if once you gather these 117 clients, what are you going to ask them?
How much time?
Yeah. In fact, how much time do you spend exercising each week? So the variable would be the amount of time a client exercises each week in the center. Does that make sense? So you don't put it, this isn't Jeopardy, you don't have to put it in the form of a question, it's related to the question. Okay, but if you put a question, you're fine. Is everybody with me still? Keep checking in with you guys, because again, really good and not sure me either. The data. So the variable's the question, the data are, if I ask a question, what do I normally get back? Answers. So data is the answers. Anytime I ask you for data, you do not start describing, you start just giving me numbers or things, right? So what's somebody could say what? What could somebody say? 6 hours, cool, comma. What could somebody else say?
1 hour.
1 hour, cool, comma. 0 hours. I'm just a member so I can show people the card and pretend like I work out, right? Or they go and they only talk. My God, get off of the machine. It's not a chair. Sorry. I don't know if anybody works that way. You guys kind of with me? Is that all right? So variable is related to the question you would ask. Data is example answers. In this case, it's example answers you would get. You just have to say 5 minutes, 24 hours, whatever, right? Is that okay? So you guys have to do a few of those. I think it's, I can't remember now, 40, 45, 48, 49. Yeah. So you have to do those, and you do it in a very similar way. So for the sample, you can use an example, and for the data, you can just give examples, right? Okay. By the way, if I ever explain something and you're like, I still don't have a freaking clue, you ask a follow-up question if you need to, right? Because I still see a few people like that, right? Okay. Anything else from homework? That was a question I basically asked myself. Anything else? Has anybody actually started the homework yet? I know a few of you have because I've actually turned it in. Okay. The minute, sorry.
Could you review the words you just went through? Just say them.
Oh.
What were they again?
Oh, these guys? The instructions? Yeah, so the definitions we went through were population, sample, variable, data, parameter, statistic. I think I said them out of the order of what they did, but who cares? Right? Group we want to say something about population. Group we work with, sample. Question we ask the sample, variable. Answers we get, data. Analysis of the data, statistic. And the parameter would just be if I had the whole population. If I analyzed the whole population, right? So a statistic would be 22% of my stats students wish I would stop talking so much, right? If I said 22% of all stats students wish I'd stop talking so much, that would be a parameter, because now I'm talking about population. Cool. Okay. Anything else from homework stuff? Okay. So, I believe last time, just kind of make sure where we left off. Yeah, we didn't get terribly far. Yeah, good. Okay, we got to there. Blah, 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 blah. Okay, so we're up to 1, 2. I like it. So now we can finally start talking about breaking down this idea of variable in data. So there's two different main types of data. All right, and again, where's my thing? There it is. Oh, you're all on the video. Hey. Scheiße. Okay. Stay. No. So the two main types of data, you could have something called qualitative data, which this book actually calls categorical, which is actually a decent name. So two types of data, two main types of data. One is qualitative. Who thinks they know the root word of qualitative? Say it. I like it. I like it even better. So qualia is actually sort of related to it. So it's quality. Oh, you say quality? Yeah. I'm sorry. It sounded like you said quality or something. It's like it sounds like a little Ewok's name or something. Anyway, so it makes sense to call this categorical data. This is non-numerical data. It's names and such, right? So a really quick example would be hair color. You can't add hair colors. You can't take an average hair color. You guys with me? So you can't do numerical things with them. They're just labels. What about jersey numbers? I just said number, didn't I? But a number on your jersey, is that an actual truly numerical thing? Or is that just another name for somebody? It's just another name, right? I could say there's number 12 down the sideline, right? Or I could say, there goes Joe, if I happen to know his name's Joe. Just another name. Okay, so this is categorical data. So it's like hair color, jersey number, Social Security number even, right? So categorical, non-numerical data. So of course the other one's going to be freaking numerical, and it's quantitative, and that's an easier root word. Quantitative. Right, the root word is quantity. Oh man, these monitors are not. Oh yeah, hold on. I have powers. Hold it. Okay. Everybody limbo. So quantitative would be truly numerical data. So now you understand what I mean when I say truly numerical? Like zip codes are not quantitative, right? You can't divide two zip codes and get something that's meaningful. But so this is truly numerical. These most measurements, like heights and so forth, are quantitative. Counts that we do, the number of BMWs in the parking lot would be quantitative, obviously. Anything that's truly numerical, the stuff that you could do, subtraction and stuff too, right? Easy, not too bad. The two Qs, the big two Qs, right? So that's not too bad. And then we get a bit of a further subdivision. Here you go. All right. So there's going to be 4 levels here. So these are called levels of measurement. This is so weird. I got such a long classroom. 4 levels of measurement. Okay. It's like a power cord. It's gonna kill me. Okay, I'll be all right. As they progress, they get more and more complicated. So the most basic level of measurement is what's called nominal. Anybody ever read any Stephen King books? Yes? Nobody else? Anybody know who Stephen King is?
One of the greatest writers of all time.
There you go. Thank you very much. Do you know what his pen name was when he started writing? There are some books you maybe never read. So I feel very excited for you.
I read The Shawshank Redemption.
Sure.
Misery.
Sure. You ever read a book called Thinner?
No.
Okay. So when Stephen King started writing, even if you don't know who the hell this guy is, he started off with a pen name. And in French, it's Plume de Nom. Nom is name. So Stephen King started writing under the name Richard Bachman. So if you like Stephen King and look up Richard Bachman, you're welcome. Some of his earliest works. Some really good shit. Okay. If you don't care about Stephen King, great. Don't look it up. Everybody with me though? Nom, name, not number. Nom is name. So this is just names. So very much like qualitative. But the second level is also qualitative. The second level is names that need to be in a certain order. So remarkably enough, sometimes again, math people just name things the right thing. It's called ordinal. These are types of variables that need to be in a certain order. Has anyone ever gone to a restaurant and they had a little thing where it's like, tell us how our service was? And it says excellent, good, fair, poor, right? You got to circle one. You with me? Even if you've never seen that, does that make sense? It's a quick way to kind of like survey the customers. What if they put fair, good, excellent, poor, or something? Would there be something wrong with that? Or have you guys ever evaluated faculty? You have to fill in the little circles. It's 1 through 6. It's like strongly agree, neutral, so forth, right? What if we gave it to you and we kind of were like, we put neutral, strongly disagree, agree, strongly agree. You say, wait a minute, this is out of order. What are you trying to do? Yes? So there are things that have to be in a certain order to make sense. So that would be ordinal. So that's some kind of ranking. This is order. Let me put it like this. Inherent order. So if I went out and I started listing off types of cars in the parking lot, there's a Chevy, there's a Ford, there's a BMW. Does that have to be in some order for you to understand what I'm saying? No. Could I put it in alphabetical order? Of course. Does it have to be in alphabetical order? No. Do you understand the difference between could be, needs to be? Ordinal is stuff that needs to be in order. Some kind of rankings, right? Okay, I like it. Okay. So these two are related to qualitative. I know. The excitement continues. I know, it's more definitions. I understand. We'll get through chapter 1. We will. And the next two are going to be related to quantitative. I'm just going to put both of them up here at once because they only make sense if I talk about both of them. Interval, ratio. If I say the phrase interval of time, does anyone know what that means? Can somebody give me an example of an interval of time?
Minutes, seconds.
Decades, I like it. So like from the 80s is an interval of time, correct? Can someone tell me how long that was? How long did the 80s last?
10 years.
Holy shit, 10 years, okay. Every interval you give me has a length, correct? And how do you figure out how long that interval is? Subtraction, correct? So if you said kids from 5 to 9 can sign up for this team, doesn't it have a length of 4 years, roughly, right? So that's the way I kind of remember. Interval is where data can be subtracted and the answer makes sense. Okay, I know this is really exciting. Stay with me though. If I had two people that had jersey numbers, one was number 23 and the other's number 21. If I subtract them, does the answer mean anything? No. One semester that happened, and of course a third person said, oh, that would be me. They were like, oh, that would be Michelle, and she was number 2. I'm like, oh, shit. But of course, in general, subtracting jersey numbers doesn't mean shit. Yes? Can I subtract 2 zip codes? Can you? Can you? Does it mean anything? Good. So that's not interval. So what about years of birth? Right? Let me tell on myself. Anybody willing to tell me what year they were born? Wait, just tell me if you are. Okay, what year were you born? 2004. I was born 1972. If I subtract those two, does the answer make physical sense? What does the answer mean?
How the age gap.
How much older I am? Yes? You guys with me? So that makes physical sense. So do you understand? If I ask you, is this an example of interval data? You just go, okay, here's one possible data point, another. If I subtract them, does the answer make sense? In this case, yes. So year of birth would be, so interval means subtraction makes sense. So an example would be year of birth. What about the stove? If you set it at 300 and then you turn it to 350, you subtract those two, the answer just means how much hotter you want that to be, right? So oven temp. Now you might then say, what about age? Age is sort of like what the year of birth thing, right? But age is more than just interval. What's the word ratio mean in mathematics? What's the word ratio mean? I'm really sorry, this is not, you guys can't see shit, is that true? I hate this room, so we're not going to say the truth. Is that better? All right. Okay. Oh, this feels so much better. Get out of here. I won't die. It's awesome. Less death of me is good. Okay. Ratio means divide. I love it. Ratio is like a fraction, it means divide. So this would be situations where dividing two data points makes sense. If I divide 2004 by 1972, I will get a number, won't I? I can do that in the calculator. Will it mean anything? Don't mean shit, right? So that's why that is just interval. But if I divide two ages, yes? Is anybody 25? No? Is anybody 20? Okay. 50 divided by 20 is 2.5. That means I'm 2.5 times as old as you are. The answer makes physical sense. So ages are ratio data. Division makes sense. A second thing that ratio has for it is 0 means what it should. What should 0 mean?
Nothing.
Nothing. None of the thing, yes? So if somebody's 0 years old, how long have they been on the earth? Not at all. Not yet. They're not on the earth yet. You with me? Okay, I like it. They haven't been introduced to the world. If I caught a fish and I said it's 0 inches long, that's another way of saying I didn't catch a damn fish, right? You guys with me? So 0 means what it's supposed to. So real quick, oven temperature. Why is that not ratio? Because what is 0 degrees? In fact, real quick, how many temperature scales do you guys know? Some of you guys might know 3. Anybody only know 2? Fahrenheit, Celsius, and the third one is? Kelvin is neat because 0 in Kelvin means we're all dead. 0 in Kelvin is absolute 0. Right? You with me? And that means absence of energy. I was doing research on the East Coast and we were cooling atoms down to like a millionth of a degree above absolute 0. Anyway, it was so cool. And they would overlap like cookies. Their wave functions would overlap and you could poke them and they'd go around. Sorry. None of that is necessary for you to know. I'm sorry. So, in our temperature scale, Fahrenheit, and we're the last country on the face of the earth to still not use metric. Go USA. In our temperature scale, or even Celsius, 0 does not mean the absence of heat, correct? I know we live in San Diego, but you know there are places that go below 0. Yes, okay. So 0 does not mean absence of heat because you can get colder. So that would not be ratio, that would be interval. That's why I put oven temperature here. Everybody with me? A little bit, okay. All right. I think I did, okay. So I have like a handout we're gonna do in a bit that will give you a chance to kind of like practice some of this stuff, okay. So my plan for today is to finish up chapter 1. I'm really sorry. I'm a little discombobulated with the room thing, so you're gonna have to excuse me. But my plan for today is to finish up chapter 1. I got like a handout to kind of practice some stuff. do a little bit of chapter 2, and then we're going to take a field trip, right? See where our office is and see where the Mass Center is. So, 2 more main ideas to talk about, and then you guys, I'm going to have you guys work in groups on this handout. Let me do this one real quick. It's got 2 parts to it. 2 other ways to break down data: discrete and continuous. This one's going to come up every now and again in the class. If I say continuous, does anyone get something? If I just say continuous, what comes to mind? Forever, maybe? Constant. Like, if I start drawing and I want to draw continuously, that means I'm not going to do what?
Stop.
I'm not going to pick my pen up. You see what I mean? Here's continuous, but that's discontinuous. It's got a break, correct? So continuous data means it could be any value from something to something. So for example, if I said, how heavy is your backpack? You might say 4 pounds or 12 pounds or whatever, right? Is it actually exactly 12 pounds? More than likely, it's like 11.8765973. And if you said that, I'd go, what the shit? But you guys with me? So weight of a backpack is a type of continuous data because the answer to it could be any number of decimals. What's the from the least weight it could have to the most weight before it breaks? Anywhere in that it could be. So that's continuous. It doesn't skip anything. So continuous just means you don't skip any possible values. It can take on any value in an interval. So like a backpack can weigh anywhere from like, not 0 pounds, but whatever the least is up to the most, and anything in between. Yes. What if I ask you, how many kids do you have? Would you ever say, and if you do, I don't want to come to your house. If I ask that, how many kids are in your house, and you say there's 3.76 kids. What? I don't know what to do with this. Is there one kid phasing in and out of reality? Is Tommy here? Yeah! And then he phases back out. I don't know. You guys kind of with me? So like if I ask you how many doors are on your car, would you ever say 3.1897 doors? No, right? That's bullshit. No, yes?
So discrete basically like whole numbers only.
Not just whole numbers, because you got to be careful. Anybody ever heard or have a car that's got an official half door? There are trucks that have like half door. There's some cars that have the half door. So you could say 3.5 doors, but discrete just means only certain values make sense. So you skip values. So sure, number of kids, whole numbers. 0, skip to 1, skip to 2. I skipped 0.1, 0.2, 0.3, and everything in between, yes? So that's what discrete means. You only certain values. But if I say, how much does your kid weigh? Number one, you go, what the hell do you want them to know? But that would also be continuous, because they could continuously get heavier. That their weight could be any number of decimal places you want to take it to, and it would make sense. Discrete just means only certain values allowed. All right, I like it. But again, if I said, how far from the school do you live? Can somebody just tell me roughly how far from the school do you live? Look at you. What's up? 7 miles? Okay, I like the 5.2, that's awesome. So 7 miles. So most of us, when you get asked the question, unless you happen to like Google it or whatever, we would say some whole number of miles. Does that mean that suddenly is discrete data? No, because it could be. It's all about what it could be. If I said the average number of people in the room over the day was 12.8. 12.875496765, whatever. Does that suddenly become continuous? No, it's number of people. That is discrete data, right? You can't have 0.3 of a person. Okay. All right. Just to remind you guys, Few more definitions, all right? Okay, so we're almost there. The next thing, unfortunately, has a few parts to it. But the nice thing is we've already talked about this a little bit. This is the types of sampling. Or a better title would have been sampling methods, but too bad. I already wrote that. So the ultimate best type of sampling, do you guys remember? What is the goal? Whenever we're taking a sample, we want it to be
Random.
random. Does anyone remember what that means? Everybody in the population has a chance to get into the sample. I love it. Every element, stay with me, of pop has chance to get in sample. Okay. I think we talked about a few of these. I know systematic came up, if I remember correctly. Systematic, automatic. I think somebody said every something, every third person or something, right? That's systematic. Systematic is basically every nth. So if I recorded the air temperature every 10 minutes, systematic. If I took every 50 feet a sample of grass, systematic. Do you understand? So it has to do with the way that I sample, not what I'm sampling. Okay. If I measured every eighth turtle that I saw, their nose, systematic, every eighth. So this is basically every nth. Okay. The next two go together. I think I talked about these two also. There's one called stratified, and there's one called cluster. Time we got. Okay. Yeah, I think around 2:15 we're going to head out for our field trip. So I just got to keep an eyeball on that. Stay with me. We're almost to the end of these definitions. Almost there. Both of these break the population into groups. So let's just pretend to make it easy, because you guys can all envision this. You agree there's other classes happening in other little trailers out here right now, right? These beautiful trailers. And they may have AC or not. The poor fools. Both of these, let's say I have 3 classrooms with people in it. So, and this is my population. So would you agree that my population has been broken into groups? I've done it twice just to have it next to each one, right? Stratified says, okay, break your population into groups and take some from each group. So this would be like in high school. Freshmen, sophomores, juniors, seniors. Let's say they want to poll the students to get their opinion about something. Wouldn't they want to make sure that they have representatives from every group? Because if they don't get any freshmen, the freshmen go, what the hell? Right? Or like, what the hell? Okay. You with me? I love this time. This is great. So stratified takes some from all. Some from all. And that's what goes in my sample. So the key phrase here is just some from all. So if I took, what, Jeff? You could do it. If I took 3 employees from every business in San Diego, that's stratified. Some from all. Yes? If I took 7 patients from every hospital, blah, blah, blah. Okay. Cluster says, that's nice, stratified. I'm going to pick groups at random and then take everybody from those groups. So I would randomly pick 2 groups, and I take everybody from those groups, and that's my sample. You guys see the difference? So unfortunately, I'd like to do this in the classroom when there's rows, but we don't have rows. So we sort of have a front row and then a next row. Okay, so just go with me. If I took 7 people from each row, that of course would be stratified. If I randomly picked 2 rows and took everybody from that row, cluster. Are those 2 examples of random sampling? What's it take to be random? Everybody in the population, which right now would be everybody in here, should have had a chance to get in the sample. Does anyone think that one of those is not random? If you think it's not random, you have to point to the people you think didn't have a chance, right? So before I do any picking, if I pick some people from each row, everybody had a chance, correct? If you're in a row, you have a chance. If I take a couple rows at random and everybody from those rows, everybody still had a chance, right? Now, if I said everybody who's enrolled in my class, why could that never be random?
Because it's convenience.
No. I'm not trying to represent Grossmont.
Okay.
That's my population, is everybody enrolled in my class. And if I pick people from here, why is there a problem? Do you think everybody is here today?
No.
Do they have a chance to get in the sample if I'm picking from the people I see? Do you understand what I'm saying? I really want to show you an example of something that's not random. Is there an element in the population or many elements that did not have a chance to get in your sample? That sucks. I like the little, that sucks. Right? You guys semi with me? Okay. So that's why it's the gold standard. That's the best we could do to try to make sure it's representative. Do you think there might be something that ties the people together who aren't here today? Maybe they know each other and they all got sick. So they have something that maybe ties them together. So if I surveyed a sample, I've left out their opinion. Their opinion didn't have a chance to get in there, it's biased. Does that make any sense? It's not guaranteed to be biased, but I can't trust it. Okay, maybe. Okay, because believe me, there have been examples where people have said, look at this study, oh my God, it says this. And then you look at how they picked their people, like, holy shit, you left out, these people didn't have a chance to be in your study. Do you kind of follow what I'm saying? There's a classic example of, I have to look this back up to see if I make this right. They analyzed planes, go with me for a second. In the war, they analyzed the planes that came back and they saw where the bullets hit. And they tried to figure out, what should we do? What was missing from their analysis, though, were the planes that didn't come back. And where they were shot, that was important information. Do you follow what I'm saying? So what they didn't really do what they wanted it to do because they were missing information from the things that could never get in their sample. It's a true story. I'll have to look it up. All right. Okay, thank God. I can finally shut the hell up. Let me give you guys this little handout that I really hope I brought. I think I did. I have a book. It's crazy. Yes. Look at me go. All right. So I don't necessarily want to do 1, 2, 3 and make you guys all move. Just can you find 2 or so people near you to work with? Is that all right? Okay. Oh, this is gonna be interesting. Trying to hand this stuff out. Let's see. Let me just do this. Good Lord. There. Okay. That goes. Wow. See? Home correction. Totally.
I just don't
Yes.
understand your.
Understood. I understand. It's all good. Holy crap. Give me 5 minutes. Sorry, you. So I just gave up on the So do just kind of get next to someone. You're all next to someone. So just help each other out of it. If you're like, no, I don't want to talk to anybody, then be alone with us. That's fine. You guys, you guys gonna be okay? Yeah, you got a notebook to write on? You're good. I'm sorry. I'm gonna bend this room to my will. Okay. All right, guys. So, who thinks they know 1A? Yes. So we have a vote for stratified. Anybody else think of something different? Yes?
I said random and stratified.
Interesting. So you can do combinations of things.
We can or can't?
You can.
Oh.
But it's a part of stratified is to randomly select from within groups. So that's a part of it. So it is stratified. Why is it stratified? The population is broken into 3 groups, right? And then some were chosen from each. Some from each stratified. All from some cluster. I love it. Strat. Why? Sorry. I feel a little loopy today. Why? Just cause. Because all you have to say here really is some from all. That makes me all happy. Okay. What is the sample? We'll start there. Or it doesn't matter where you start. What's the population? Anybody know what's the population? I like it. All Ecuadorians. Anybody from Ecuador? Is that the way you say it? Nobody from Ecuador? Okay. How did somebody identify the sample? Yes?
Group of 91 white drinkers, 82 light or heavy, 82 light and 88.
That is fine. Somebody else say it a different way. That's fine.
I said 261, so
Yes. Okay. So I want to really understand. That's beautiful. Or you could just very often if you know the population, you replace the word all with the number. And what'd you get? 261? I can't remember how many total I had in there. 261? Okay. 261 Ecuadorians. Holy crap. Okay, I just made a single letter out of 2 letters. I love it. Again, if you wanted to be able to read your teacher's writing, you have chosen poorly. Now, if they find that the percentage of stomach cancer occurrences in their sample was 3%, is that a statistic or parameter? Statistic. Why is it a statistic? It describes the sample. Kick ass, right? How would it change that to make it a parameter?
His sample, his population.
Yeah, if they found that the 3% of all Ecuadorians, okay, that's a parameter because it's describing a population. I love it. So it's a stat. Y describes sample. Is everybody with me? And real quick, I want to point this out. I always get these weird answers for sample and population. Sample and population are both groups. So if you write an answer down for a sample and it's not a group of something, it's wrong. Right? Population and sample are groups. Okay. Number 2. What level of measurement? Blah, 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 blah.
Ordinal.
Yeah, I like it. So ordinal makes immediate sense. Why? Yeah, it determines how they take you. It puts you in order, correct? I mean, that's the fundamental reason for it, is to put you in order. Did anybody have a different answer? So let's say you go to a deli, it's got a normal thing where you pull a number, so it's 6, 7, 8. Has anybody ever gone to the Panera, for example? I don't know if they still do. I think they give a buzzer now, but they used to give a number, but the number was random. So you would get 157, and the next person would get 10. They still kept you in order, but the number you got wasn't in order. I'm like, that drove me a little crazy. As a math person, but let's say you go to deli, 1, 2, 3, 4. You got the number 4. This person's got the number 2. 4 minus 2. Does it tell you anything physically? It does. They're 2 places closer than you are to getting something. Yes. So you could argue that that is interval. You can understand what I'm saying? So I would accept either answer depending on how you explained it. That's why the most important part of that question is why. If you leave that part blank, you're going to lose more of the points. Because that's the important part, is why. Okay. Maybe. So if anybody was thinking interval because subtraction makes sense, that would be acceptable also. Subtraction makes sense. Now, you can't just say this. You'd have to actually give me examples. Number 4, number 2, 4 minus 2 is 2, 2 spots, blah, 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 right? So I'd probably rather answer ordinal because it's quicker to answer that, but up to you. Somebody semi with me, okay. So you're not used to having a math problem where there's two possible answers, right? Okay. What about this one? This one always trips people up because you pay attention to the wrong thing. Nominal. The percentages weren't the data. What were they asking people?
Hair color.
Hair color. Hair color is totally names. Nominal. Nominal. Hair colors. So don't look at the numbers they give you. Look at what the variable is. Look at what the data could be. Same thing goes for the next problem. The fish weighed 2 kilograms. The fact that they said 2 doesn't make it discrete. Again, discrete continuous is all about what could it be. Could it be 1.98743 ... kilograms? It still makes sense. I like it. Even though it's kilograms and we're in the US and you're all like, oh my God, it's metric. Oh. Okay. So this is totally continuous. Why? Because it could be, oh my God, Jeff. It could, this is roughly English. 1.99876 ... That's beautiful. That's a great way to explain it. Okay. Or you could say it doesn't just have to be 2, 3, 4. It could be anything, right? So I'll accept a few different ways to answer it. Somebody with me? So like here, don't look at 2.3. Don't say, oh, it's a decimal. It's got to be discrete. What is it that they actually recorded? What were they asking? What were they looking for? Number of TVs. What they do with it, average. Who cares? What were they doing? Number of TVs. Is that discrete or continuous? Discrete. If you tell me you have 1.79 TVs, what? What does that mean? Okay. So this is discrete. Can only be, in this case, it can only be whole numbers. What's it, real quick, you've all heard jokes about like the average number of kids a family has is 2.5. Something like that, right? Used to be 2.5. You guys with me and everything, and then people are like, I don't want to see that half kid. What is that? What the average can be anything, correct? If I have 10 families and there's a total of 25 kids, that's all good, right? It's all making physical sense. 25 divided by 10, 2.5. So the average can be anything, because we're dividing. So who knows? All right. Any questions from this? This is how I like my first quiz to look, hint, hint. Not exactly this, no. You will never get a question you've already seen, but I do, my first quiz looks very much like this. Okay. All right. So now, what time we got? Oh, we got so much time, it's too bad for you guys. That clock is correct, yes?
Yes.
Okay, thank you. I have some rooms where the clock doesn't work. I have some rooms where the clock is telling me what the time is in Hong Kong or something. I don't know. All right, guys, let's do some actual working with data instead of definitions. Does that sound okay? Does everybody want more definitions? No? Okay, good. Just to make sure you understand what just happened, section 1.4 are some definitions. I'm not going to talk about them. You're going to read that section and do the homework. Yes? So the textbook exists for a reason. I like to kind of leave some stuff out and make you read about it. You know what? Okay. Section 1.3 sets up the idea of something that's going to be used again in chapter 2. So I kind of personally like to do section 2.1 first, and then I sort of do 1.3 and 2.2 because they go together. That doesn't make a lot of sense at the moment. That's what I'm about to do. Okay. So section 2.1 is in a chapter called Descriptive Statistics. So you have two main branches of statistics. You have descriptive statistics and you have inferential statistics. What the hell does infer mean? If you infer something, what does that mean? Does it mean you wrap it in a fur coat? Guess, okay. Right, so inferential statistics is when I take something I see in a sample and I try to apply it to an entire population. You with me? Even if you don't care about elections or anything, has anyone seen any information about the polls? Like it looks like 40% are going to vote for this person, so forth. Right? Say again.
Popular vote?
Sure, popular vote. We can get into electoral college. Let's not make this a government class, but I'm a little bit of a political wonk. I love keeping track of politics. I don't blame you if anybody here's like, good Lord, no. Okay, I understand. But please, dear God, vote. I'm not going to tell you how to vote. I don't care. Just the more people that vote, the better. I'll stop. Okay. Now, if you see when they say 40% of Americans are going to vote for this person and so forth, they base that on a sample, but they're trying to say it as if it's everybody. Are you with me? If you pay really close attention, very often at the bottom it'll say plus or minus 4%. Has anyone ever noticed that? They'll give like 40% are going to vote for Jimmy, and 42% are going to vote for Frankie. Right, and at the bottom it says plus or minus 4%. So if you look at this, who looks to be ahead? Frankie, right? But it could be 44 to 38. Do you understand? It could be plus or minus 4%. So this could go up 4 and this could go down 4. Do you guys understand what I just said? Later this semester, we are actually going to learn the math that goes into that number. They didn't just go, I don't know, what do you think? Give or take 4. No, there's math that goes into it. One thing that affects this number is how big the sample is. Does that make sense? If I get a bigger sample, this number should probably go down because I should be more certain about what I see, correct? So we're going to see how the sample size goes into calculating this number. I love it. And you guys are like, oh, yay, Jeff. I'm excited. Okay. Sorry. All right. So descriptive statistics is not that. Descriptive statistics is just how do I present to somebody what I saw in my sample, and that's it. I'm not going to try to make an inference about anything. The most basic way, so here's an example. Let's see. Let's say I ask a bunch of people, how many TVs? I don't care. Let me think. Sure, that'll make. Well, let's do it. How old they are, and here's my answers. Okay, all right. When I'm doing this little lecture stuff, I'll just make data up. When I give you quizzes and tests, I like to give you actual data. And I'll even give you the link to it if you really feel like going to look at the data. All right. So obviously, I did not just go ask people their age. What's a very important thing to note, this data is already in order, correct? So one of the most basic things we're going to learn, next time I'm going to bring all my calculators in case you don't have a calculator yet, and we're going to learn some basic shit. So you can put data in, you can ask the calculator to sort the damn data. Because having it sorted is very useful. Okay. One of the most basic graphs I could give somebody is called a stem and leaf plot. The book is very boring. It's not boring anybody. The book is boring, it just calls it a stem plot. Its real name is stem and leaf. So let me see if I can make this make sense. Aren't there a bunch of people in their teens? Some people in their 20s, some people in their 30s. One poor old guy in their 40s. Or some 50s. And some people not even teens yet, right? So my stems would be the first digit, and the leaves are the numbers that come off of that first digit. So leave some space here. So put a 1. There's teens, 20s, 30s, 40s, right? What would the first digit be for these guys? Beautiful. All right, good. You with me? So next to 0, I would put 4, 6. What do I put next to 1? No. 5, 8, 8. So the stem plus leaf equals number. I like it. 2, 4, 9, 9, 9. Next to the 3 goes 0, 4. Next to the 4 goes 1. Very simple. Yes? We're not quite done with it, but let me point something out. If you just do this with your head, doesn't it look like a graph, like an actual graph? You can see the height tells you where the most people are. So of course it's a very small sample. So if I had a larger sample, this would be more descriptive. Are you with me? But it's already, you know, where were most of the people in their 20s? We can just see that very quickly from the picture, right? What's missing still is a key. What does a key mean in this case? Well, I'll show you. So, how do you read this? What does this mean when I see that? 15. Okay, why do we need the key? Because, let me stop right now. Is everybody cool with any questions on that? That should be really, really straightforward. That's almost scary straightforward. Like, okay, the whole class won't be this easy, but this should be really easy. Yes?
I don't get it.
Oh, what's up?
What is the key again?
Oh, it just tells me how to read this. Now let me do one thing and see if you get it better. Because I understand, without a comparison, you don't know what the shit that is. Don't do anything right now. Don't copy this. Couldn't I have asked people, how heavy is your backpack? 0.4 pounds, 0.6, 1.5, 1.8, 1.8, 2.4. Don't do anything. Dear God, I don't want your notes to be crazy. 3.0, 3.4, 4.0. You guys with me? That would look exactly the same. That is exactly the same. How do I tell people to read it? Okay, now you know how to read it. Right? Something, line, something means that, point, that. So this is 3.4. Does that make more sense? I need the key because what are you going to show people? You're going to show people this. You're not going to show people the data. You're just going to show them the graph. So if I just show this, I don't know how to read that. I need a key to tell me how to read it. Does 1.5 mean 15? Or does 1.5 mean 1.5? Or does it mean 0.15? Or does it mean 1500? Does that make more sense?
Yeah.
Okay. So yeah, I knew it didn't make a lot of sense by itself. You have to see the comparison. Yeah. So if I ask you to create a stem and leaf plot and you don't include a key, you're going to lose some points. Like it. Okay. Some of you guys are like, don't talk about losing points. Well, then don't do that. Don't lose points. Now, there are a few things in chapter 1 I'm kind of skipping over. So there's some things called ogives and weird shit that's very rarely used. Stem and leaf is just really basic. So we're definitely going to do stem and leaf. The only time, real quick, let me add one data point. What if I had 67? How would that change anything? I love it. You put a 5 and a 6, and you put a 7 there, right? 67. You have to show empty classes, right? So this would be an empty class. Does that make sense? You have to show that. That shows me gaps. That shows me if there's like a natural gap in the data or something. I was about to say bimodal, but that's a little too early for that. Yes?
If you put a 0 by a 5, would that be 50?
That would mean 50, and that would be lying, right? So we wouldn't put anything next to the 5, because that would just mean there's nothing there. But I have to show people there are empty classes. Does that make sense? Okay. Notice how I didn't put a 7. Why would I put a 7? Because it doesn't go up that high. Who cares? I don't need to show 7, 8, 9, 10, 11. You just keep going forever. No. Okay. Okay, like it. Now, that's really simple. I love it. Let that be nice. We're going to take a step. Oh, this is beautiful. Sorry. Time's just going slow. I love it. I'm going to take this away. You guys are all like, yeah, it's going slow. What I'm about to do, part of it is in section 1.3, and the rest of it is in chapter 2. Let's see. No, I don't want to do this. Too many people. I'm going to make up some more data. Yay. 16. All right, that's plenty. So this sort of represents, well, yeah, sure, why not? Well, you know, there are some students who are in what's called the middle college that are attending college courses, but they're still in high school. There might be some people in here, I don't know. So this could be like a makeup of a normal class. So it's heavy towards the bottom end, and then there's a few of my older students. Okay. So what we're about to do is, have you all seen pictures that look like, there's 2 ways to see this. This maybe, like maybe this is BMW, Hyundai, Ford, right? And then you have numbers here, 1, 2, 3, 4, 5. So like numbers, like there would be 3 BMWs in the parking lot, so right? Does anyone know what that's called? Bar graph, kick ass, because it's a graph with bars. Math people were like, bar graph, graph with bars. Then you have another one that's almost the same, but it is different. So maybe this could be grades in a class, 60, 70, 80, 90. Ooh, Jeff, wow, look at the 110. Yeah, gave some extra credit. Histogram. What is the main difference? It's actually something we just talked about earlier. Yeah, here the scale is made of qualitative data, right? And here the scale is made of quantitative data. This gap, does it mean something's missing? No, it's just the gap between this word and that word. If there was a gap here, what does that mean? That means nobody, sorry? No one scored a 90 to 100, right? You guys with me? So this is a true scale. If there's a gap, that means you're saying there's nobody there. This is not a true scale. There can't be a scale because there's frickin' words, right? So gaps don't mean shit. Are you with me? That seems to be an important point. So we're gonna come back to that in a bit. All right, now, yeah, this will work here, yes, okay. I got time, good. So look at this. Let me make something up here real quick. All right, so let's say this is 5. What does that mean from 60 to 70? What does that mean? 5 people, 5 students scored between 60 and 70, yes? We call these classes. So each of these is a class. Right? So there's like one empty class the way I've drawn it now, right? How wide is each class? 10. You with me? That's easy to see, yes? We're doing that, but we're doing it backwards from that. That's one that's made, and we're just reading it. We have to create one now, which means we have to figure out a couple things. We got to figure out how many classes do we want to use, and then how wide does each class have to be? We have to figure out the class width. Does that make some sense? Okay, so to explain the math of this, can somebody tell me, let me say this. Let's say this corner of the room is at the 10-foot mark, and that corner of the room is at the 28-foot mark. 10-foot mark, 28-foot mark. How long is this wall then? 18 feet. And let's say 1, 2, 3, 4, 5. That's crazy. I love it. So there's 6 panels, correct? How wide would each panel be? You took how long it is divided by the number of panels, correct? Okay, everybody get the physical idea then. You're all like, yes, Jeff, good job, buddy. But I need you to understand the math we just did, the physical math we just did, is exactly what we're about to do with just these freaking numbers. So where's the data start? Where's it end? How long is that? Just like how long is that? There we go. Now, the number of classes we use is going to be somewhere between 5 and 10. You use more classes, the bigger your sample is. We're never going to have a very big sample. So if I was a student in this class, I would only ever use 5 or 6 classes. Are you guys with me? You guys understand? 4 is 4 good. 4 is right out. 4 sucks. 4 is not enough. You got to use 5 to 10, and we're going to use 5 to 6. If I gave you 1,000 data points, you might use 10 classes. Do you want me to give you 1,000? I don't want to give you 1,000. No. Okay. So I'm not going to do that. So let's say we'll use 5 classes because this is a pretty small sample, right? So the exact same math we just did. How long is it? Well, in this case, it's 29 divided by how many rectangles I want to use. Yeah, rectangles. So rectangles. Ooh, right? And let's say we use 5 rectangles. So how wide would each rectangle? How wide would each rectangle have to be? By the way, watch this. Cool trick to divide by 5. Double this, right? If you double 2.9, 29, what do you get? 58 divided, and then move the decimal back once. 5.1. Right, or just do any calculator, I understand. Let me stop for a minute. That's exactly, right? I want to know how wide each of my rectangles, those are freaking rectangles. The exact math we just did there, it's the same idea as this. How wide does each rectangle have to be to cover the whole thing? If you get a decimal here, let's just round up. Let's round up to 6. If you get a decimal, round it up. Make it a little easier on us. We're just human. So the class width, oh man, that's my 4th puberty. The class width is the range. The range is just the highest minus the lowest, divided by the number of classes. That's our first official little formula. To figure out how wide your classes are, you take the range, high minus low, divided by the number of classes you want to use. Everybody with me? So when they did it, they did the whole work and they got 10 for their width. That's why it's 10. Crazy sauce. Okay. So we want a class width of 6. All right, let me see. Where can I go? I have no room. Has everybody got all this? I need to keep my data up there, but I need to make some room. I'm going to get rid of this. Make sure I'm getting all this. There we go. I don't need these guys. Okay. So, the lowest data point is 16. So I want the first class, I'm going to figure out what it's going to end at. If the first class starts at 16, and the classes are all 6 apart, where should the next class start? First class starts at 16. Classes are 6 apart. So the next class starts at 22. If I put a 22 here, there's no 22-year-old, of course. But if there was, where would the 22-year-old? So if I put the 22 here, I don't know where to put the 22-year-old, which class it goes, right? So let me make sure you really understand. I can see the width here. And whatever number that is, that's 1 less. I'm going to show you a different way to do this. This is the textbook method. I'm going to show you the way that I do it, and then you can choose. Okay, I like it. So everybody see why that's true. So don't say, oh, it's 5 with, no, it's 6 with, and that has to be 1 below, so you're not like repeating a data point. So all you have to do now is just keep adding 6, because that's how far apart everything is. Add 6 down, add 6, add 6. You can do it, Jeff, there. Add 6, add 6, add 6, add 6. Okay. 1, 2, 3, 4, 5. Ooh, neat. I like it. I didn't know I was in a movie. So now that I've got the classes set up, what was it about the height of the rectangle that told me what now? Like the height of the rectangle from 60 to 70 went to 5, right? What did that tell me again? Then 5 people scored between 60 and 70. So I want to do the same thing. I want to count, and it's called the frequency. I want to count how frequently a data point shows up between those two. So how frequently does somebody's age occur from 16 up to 21? A lot. 8, 9? 9? 9. Okay. All right, keep going. Yeah, so there's 3 in the next one, right? Yeah, the next one, there'll just be 1 poor little person. The next one, 2, and the last one, 1. How many data points were there? 16? So those better add up to be 16, yes? It's a way to check yourself. What really sucks is if you add those up and you get 15, you're like, oh shit, which one did I leave out? Right? So a lot of those summertime jobs, it says earn so much money from home. That's data entry jobs. Yay, data entry. So the worst part about this statistics in general is just the part where you have to enter the data. That sucks. So if you miss one, that sucks. But thank God this adds up to be 16, right? Now, this is a horrible example for so many reasons, but it's pretty easy to tell where the most people are. But there's something that we created, that humans created to help us understand numbers better. And we created percentages. So I want to create percentages for each of those to tell me how big a piece of the total group is in each. How do I construct that percentage? How many people are in the first group? Out of? There you go. So that's exactly how to make a percentage. And we call it the relative frequency. Yeah, relative frequency just means percentage. So what's 9 divided by 16? Can I do that? Let me see. Can I do that? 116. I think it's 0.56 something. I'm very wrong, probably. Is it? What is it? 0.57 basically, right? If you round? 0.56? 2? Okay. That was decently close. 562. Okay. So that'd be 56%. Is that cool? So it makes sense. A little over half of the people are in there. So keep going. What's 3 divided by 16? Point 18? And that's rounded correctly? 19, okay. 19%. 1 divided by 16. That's 0.0625. Sorry. Yes? Look at Jeff go. So 0.066%. And then 2 is going to be 0.125. And then 3, 16, we already did. Exciting. The math is not very difficult. It's different how we're using it, but it's not very difficult. Okay, like
The
yes.
last one is 3 out of 16.
Yeah, 3 out of 16, which is 19%. Is that right?
But
supposed to be
the
1 out of 16,
difference
1 out of
is
16.
Oh, thank you. That's what happens when you're like right on it. 6%. That would have shown up in a second. You could have just let me, you're like, let him figure it out. What should those all add up to be? I would have really been like, oh shit, what did I do? So why might it not add up to be 100? Because we rounded. What do they add up to be? Has anybody got that? 25, 81, 93.8. I got 99.5. I don't know what anybody else got. You got that? Which is close enough to 100%. We rounded, so it could be anywhere from 99 to 101%. If you get 95%, no. If you get 107%, hell no. Right? You suddenly created people, which is something we can do, but normally not that quickly, right? Okay, so now I want to construct a picture like the one I had up earlier with the grades. Okay. Yes, I can get rid of the data. I don't need you anymore going. What time is it? Okay, this is perfect timing almost. Oh, you're gonna love this shit. Okay, I'm gonna do this whole problem by the textbook, and then I'm gonna show you the other way, the way that I would have done this, and it's gonna make this shit a lot easier. So let me say something that seems very out of nowhere. There's a limit to Jeff, right? Jeff ends here. You agree? I love it. Jeff doesn't extend, right? This is me. This is the limit of me. And you're all like, I think he's off his meds. Just go with it. Then there's a boundary that if you step in that boundary, I better know you. Everybody agree. Do you understand what I'm saying? If somebody gets right here, you better know them. You better want them there, right? Are you with me? So there's a limit to me, and then there's a boundary to me. These are the class limits. If I were to try to start graphing this, wouldn't it sort of look like, wouldn't there be an empty spot right there? Do you guys see that? That's no good, because that would mean there's an empty class. Are any of our classes empty? Shit, we don't want to lie. So what do? Here's what you do with the textbook method. You go down a half, up a half. Limit, go out a half, boundary. Yes? What does that do for me? If I go down a half from here, I go to what? Do you see how those overlap now? No space. So it'd be 15.5 to 21.5. And the great thing is, what was the width again? 6, you see, keep adding 6. 27.5, 33.5, 39.5, 45.5. Good Lord. Even when I really try, I can't write. That's the textbook method. Let me go ahead and show you before we finish this. The way I would do this, my first class would look like this, and now you'll quickly see why people don't like to do it this way. My first class would look like this. Then the second class would look like this, and so forth. People don't like, very often, unfortunately, they don't like algebra. So there's a variable in there, there's inequalities. Where does 22 go? Which class? First or second? Yes, because that's the one that's allowed to equal 22. This one's not allowed to equal. Do you see that? If I do these like this, then that's 16, that's 22, that's 28. If I do these like this, the limit equals the boundary. Exciting. So it's just the choice you make. The book is going to do it more like this. Personally, I like this, but I don't care which way you do it. You don't get extra points for doing it the other way. All right, so let's stick with this way for a minute. If I'm going to make a relative frequency histogram, I'm going to use the percentages. How high do I need this to go? What's the highest percentage? What's the highest percentage? 56%. So maybe I go 10, 20, 30, 40, 50, 60, right? There's no reason to go up to 100 every time. You almost never want to go up to 100. Because then all your little, then I get people that turn stuff in, it looks like this. I can't see that shit. Give yourself some room, right? So how tall is the first rectangle going to be? No. Real freak. 56%. How about the next rectangle? Pretend like this is good. Next rectangle. 19. And then 6. And then 12. And then 6. Okay. Pretty standard histogram of ages in a college classroom. Fascinating. So now you're going to have to be able to do all that yourself, right? So there's a certain phrase I never try to say too early. Next time we'll do a worksheet that gives you practice with stem and leaf and these histograms and so forth. Let me announce this right now. Our first quiz is going to be a week from today, so next Wednesday is going to cover chapter 1. My quizzes, we finished chapter 1 today, yes? So when is that homework kind of due roughly 2 classes later, which would be next Wednesday? So I try to schedule my quizzes on the day that you should be ready to turn that homework in. Are you with me? Okay. So, we're going to take a little field trip. It's going to be quick, I promise. And once we're done with it, you guys can just go wherever the hell else you want to go, within reason. If you need